based on the terminal average. They should always be based on the average.
Yes, the accounting product is always average. Yes.
Yes, and the
No, the denominator, which is the investment, you'll always be told in an exam question whether to use an initial method, that's an initial investment, or average investment. You will be told.
Yes. Okay. Thank you.
All right. Okay. So let's look at our terminal value. Okay, terminal value. So first, like I said, the next set of topics is all under one umbrella called the DCF techniques, the discounted cash flow techniques, which includes mainly two main topics. That is the net present value method and the internal rate of return method. But in order to do internal rate of return, you must be able to know how to do your compounding and how to do your discounting. So to do the compounding, we call that calculating our terminal values. Okay, I'm sure we have all done this in one way or the other in our previous studies, because I remembered when I was going to primary school, as part of the mathematics syllabus in the common entrance, we used to calculate compound interest. I'm sure even now this element must be there. So it's the same thing, you know, compound interest calculation is the same as terminal value calculation. Okay, so what do we mean by terminal value or compounding the interest? Okay, for example, you want to go to the bank and either make a fixed deposit or you want to open a savings account. Okay, let's say you have $100,000. You want to save it for a period of, let's say, 2 years. Okay, and then you went to the bank, you asked them, say, okay, I have this much money, 100,000, and I can save it up to 2 years. I won't need it for up to 2 years. What interest can you give me? Okay, they will say, okay, we'll give you 5%. Or you negotiate. Okay, they say I can give you 7% or 6%, like that. So what you're going to do is, before you take a decision, as an accountant, you have to calculate how much will I get, if I invest this in a savings account that will fetch me an interest rate of, say, 7% for over 2 years. Okay, so you will use this compound interest technique to be able to calculate, so that at the end of the 2 years, you will have that much interest. Okay, and once you know that, then you could say, okay, now let me, because you have the money, don't just rush and invest it like that. You have to look at, various avenues of how to spend, of how to invest that money. Okay, as an accountant, this is why we go to school, especially us who study accountancy. So if our studies is going to be of any benefit, it should benefit us first, okay, before we can, advise anybody. So you say, okay, let me see, okay, 7%, okay, for 2 years. Let's say it's going to give you, let's say, $14,000. So over 2 years, you're going to get only $14,000 from your investment of $100,000. I'm just giving you a scenario. I've not calculated it yet. Okay. So now you say, okay, but let me go to a real estate company and see what's going to happen. If I can get a land for, say, $100,000. If I buy this land for $100,000, I need to find out how much will I be able to sell this in case I want to sell this in 2 years. And then you'll be able to have an idea. You can be able to talk to, real estate, managers, and then they can advise you. If you have to sell this in 2 years, how much you can sell it for. Okay? And then you'll be able to compare what you're going to get when you buy a piece of land and sell it in 2 years versus what you're going to get if you invest it in a bank account, at 7% over 2 years. Okay, so Can you see some of the importance of these little calculations we are doing? Okay, is this not going to be of benefit to you as an individual, much more as an organization? As an organization, like if you work for an organization, naturally it's going to be a lot bigger than this. The organization can have some some excess liquidity. Okay, some excess liquidity, and will need to invest those excess liquidity. So you need to do some calculation to advise them. Okay, so these are some of the things that you're going to do. Is that clear?
Yes, sir.
Okay. So it's not about learning different things, but it's about how you're going to use those things and applying them in real life. Okay, you could even advise, how to call it, people who run these small businesses, SMEs, so on and so forth. The only problem with Gambians is people want to keep up things. Nobody will want to let you know how much money they have, especially the small businesses. Okay, but these are all the creative areas that we could give advice to as accountants. Okay, so we have lots and lots of areas that we can work, even at personal level. Okay, so let's look at the question that we have here. Suppose that a company has 10,000 to invest and wants to earn an interest of 10%, okay, compounded. This means that the 10,000 should be invested at 10%. The value of investment will look like this, okay? After 1 year, the 10,000 will be 11,000. After 2 years, that 10,000 will become 12,100. After 3 years, it's going to be 13,300. So the extra on top of 10 are the interest, isn't it? Okay, so how do we calculate this? We calculate this by making use of the compound interest. So compound interest is simply the future value of the investment now. If you invest an amount now, what will be the value of that investment after 1 year, after 10 years, or after 50 years, like that? Okay. So, and then as accountants, because we are not very good mathematicians, we like to do little formulas here and there, because otherwise you don't need any formula with this. So the little formula that we are able to derive here is this: V is equals to X into bracket 1 plus R raised to power N. V is the terminal value, or the future value, is equals to X. X is the now value, the value now. X into, that means X multiplied by 1 plus R. R is the rate, that means in this case 10%, 0.1, raised to power N. N is the number of years that's going to take for investment. Okay, 1 year, 2 years, 3 years, like that. Okay, so if we use our calculator, okay, we will be able to compound this easily. Okay, so you can put in your calculator. Let me project that. I'll show you how to do it on calculator, and we'll work it on an Excel as well. Okay, right. So let's just go back. I'm going to project my calculator. Okay. Can you see this calculator? Can
Yes.
you see? Excellent.
Yeah.
Okay. So now the question is, our investment 10,000, what will be the value after 1 year, after 2 years, after 3 years? The interest we're going to use will be 10%. Okay. Using our formula, V is equals to X raised to power 1 plus R to power N. Okay. So for the first year, it's going to be 10,000 multiplied by 1.1 straight. That's easy. Okay, so I'll do that on a calculator. Okay, so please, I'm advising all of you to have a scientific calculator before you go to that exam hall. Okay, there must be a question that will include either a compounding or a discounting. So you can't go to the exam hall without a scientific calculator. Okay, so this is why I'm trying to project the scientific calculator so that you can be able to know how to use it. Okay, you are not going to do your exams using computers. You will not take your computer with you. Okay, but you are allowed to take a scientific calculator with you. Okay, something like this. I usually use a Casio calculator, or if you can get any other scientific calculator, it's fine, because all of them are very, they have very similar features. Okay, so after 1 year, our investment is going to be like this. So we say 10,000, just type 10.
Hello, sorry,
Okay.
Mr. Fafama.
Yes.
Yes, about the exam, you say which one, you know, what and what topic must come? I mean, this one you mean?
No, we have not discussed about the exam yet. What I'm saying is this topic will definitely come in exams. So as such, you need a scientific calculator. Okay? The DCF technique, you need a scientific calculator. And it's such an important topic that it comes in every exam in MN3.
Okay.
So that's a good tip, Mohammed. That's what you want to hear.
Okay, thank you.
That's what you want to hear, isn't it? Okay, right. So 10,000, so we're going to compound it. We say 10,000 multiplied by 1.1. You know, any number raised to power 1 is always that number. I hope we all know that. You know, we've all done our little mathematics before we are here. All of us, isn't it? So you need to know, you need to have some mathematics knowledge before you can be able to do accounting. Very, very important. That's why they insist that you must get a credit in maths before you can enroll for accountancy. Okay? Any number raised to power 1 is always that number. So 1.1 raised to power 1 is 1.1. So there is no need to, in fact, raise it to power 1. So that's why when we compound 10,000 multiplied by 1.1, it gives us 11,000. Can you see my calculator?
Yes.
Okay, good. So this is it. Then now let's compound. Let's go to the second one. For the second year, after 2 years, investment of 10,000, we're going to compound it. So it's going to be what? V is equals to x raised to power, x into 1 plus r raised to power n. So what will be r in the formula?
R will be 0.1.
0.1, which is 10%. So that in the bracket we'll have 1 plus 0.1, which is 1.1. Okay, the raised to power n. What is the raised to power n?
It will be 2.
It will be 2. So n is the number of years. The number of years here is 2 years. Okay? So when we do that on our calculator, so it's going to be 10,000, 1, 2, 3, multiplied by, bracket opens, 1 plus 0.1 is 1.1, isn't it? 1.1. Then the raised to power, take note, in some calculators is denoted as x to power y. In other calculators is y to power x, and in some calculators it's like a v on top. Okay, I think it's number 7. I think Arabic alphabet number 7, isn't it? It's like v, but is on top. Okay. It's like the reverse of v. Okay, the reverse of v. Okay, so that's the sign for a number to power. So, but in my own calculator here, it is x to power y. So once I click that, then now it's gonna open a bracket for me to type the power. So since it's 2 years, so I'm going to type 2 here. Okay, so once I type 2, look at it, it has given me the answer, 12,100. So try this on your calculator, please. If you have a scientific calculator, try it. You must be able to know how to do this, okay? Can you try it on your calculator?
Sorry, Mr. Fofana. I'm not.
Yes, ma'am. Mm-hmm.
I got what you have got, but I'm not using scientific calculator.
Sorry?
I have what you have got, but I'm not using scientific calculator. I don't know whether this one will also apply. The normal calculator.
You use it with, which calculator are you using?
The
Maybe
normal
it's
calculator.
Casio.
Yes, Casio, exactly.
You are using Casio calculator.
Yes.
Yeah, that one also works.
Yes, it's a scientific calculator. Casio
Yes.
is a scientific calculator. Yes, it's gonna work.
I never know.
Yeah, that's it. That's it. Casio. Well, you have Casio. You have a normal Casio calculators, but you have scientific calculators of Casio as well. So, but if it looks something like this, then it's a scientific calculator. Okay, Omar.
Okay, thank you.
Right. So if you do raised to power 3, the same thing. So I just clear. So I say 10,000, 1, 2, 3, multiplied by 1. Sorry, before that, let me just open the bracket. So 10,000, 1, 2, 3, multiplied by bracket opens 1.1 raised to power 3 equals to 13,310. Okay, so that's the way we do our compounding. Okay, it's clear, everybody?
Yes.
Okay, so can you find the terminal value of 200 at an interest rate of 7% for 10 years? Can you do that? Everybody, can you do that and tell me the answer, please? Now.
Okay.
What is the interest rate?
7%.
Okay. How many years?
10 years.
That is 40,000.
How much have we got?
320.
40,000?
320.
40,000?
320.
4320.
Yes.
Mr. Fugan, is it 200 or 200,000?
I tried this out.
No, only 200. 200 only.
For me, I got, you mean
Yes.
7%?
Huh?
7%.
7% for 10 years.
That one, for
It's
me, I got
393.
393. Yes,
393. You got 393. Omar, you got how much as well?
yes, 393.4.
393. Dumbia, why did you get that much? 200,000 plus? Sorry, 40,320. Where did you get 40,000 from, Omar? Dumbia. Dumbia, are you with
Sorry,
us?
you said okay.
It can be miscalculation,
Yes.
but
I did not say 200,000. I did not say 20,000 also. I said 200. 200 only.
At the interest rate of 7%.
200, interest rate of 7%. If you have 200 pounds, you want to invest it in a bank, the bank has given you an interest of 7%, and you want to invest it for 10 years. How much are you going to get at the end of 10 years? Okay, let me do it. Check on my calculator. So 200 200 multiplied by bracket opens, okay? 7 plus 1 plus R will equal to what?
1 plus 0.
1.7.
I think
No, not 1.7.
1.07.
1.07, exactly. 1.07.
Yeah, that's where I have a mistake. I used 1.7.
Okay, 1.07. 1.7 is 70%. Mind you?
Yes, that's where I made a mistake.
Okay, so 1.07 raised to power 10. So you type 10. Okay, so 393, correct. 393. That was correct, Nima and Umar, correct? Okay, so that's the way we do our compounding. So let's move to discounting. Let's move to discounting. Okay, are we together?
Yes, we are.
Okay, this was the scientific. Okay, so discounting is the very opposite of compounding. In compounding, what do? We have a value now, an investment now. We want to find the value of that investment after some years. Discounting is the opposite. We have done our estimate, okay? When we invest, we are saying that we're going to get this much, okay? We want to find the value now. Let's say when we invest, we're expecting to get 500,000 after 5 years. We want to find what is the value of that 500,000 in 5 years to now. We will know one thing, that is the value of 500,000 in the future will not be the same value as at now. But the question is, as at now, is it going to be more or less?
As at now, it will be less.
It will be less.
It's going to be less.
Because the time value of money says that money today is more valuable than money tomorrow. So if you have 500,000 in 5 years' time, that 500,000 cannot be 500,000 now. Okay, it will be less than that. Okay, it will be less than that. So, simple reason, in the future, we expect, of course, inflation to occur. So the money you have now is definitely more valuable than money tomorrow. Okay, so let's look at how discounting works. So when you are doing your discounting, if we want to use a formula, simply we turn the formula upside down. Okay, in our formula, which says our formula for terminal value says V, which is the terminal value or the future value, is equals to X bracket open 1 plus R raised to power N. X bracket open means X multiplied by 1 plus R raised to power N. So if you are going to make X the subject of the formula, of course, which you are doing now, because now instead of finding V, you are finding X. X is the value now. Okay, is what you are finding, isn't it? So if you are finding X, the present value, okay, you're going to make X the subject of the formula. Simply, if you want to make X the subject of the formula from our little mathematics, we are going to reverse the equation, isn't it? So where it says V is equals to X multiplied by 1 plus R raised to power N, if we want to make X the subject of the formula, is going to say X is equal to, instead of multiplication, is going to be divided. So it's going to be X is equal to V divided by 1 plus R raised to power N. Okay? So the multiplication sign has changed to the division sign, because when you are, how to call it, a particular equation, when part of an equation crosses to the other side of the equation, the, how to call it, the sign changes. Okay? I hope we all know that, yeah? So that's simply how we arrive at our discounting formula. Okay? Is that clear, everybody? So we made X the subject of the formula. Can we remember those simple mathematics that we have done before? I'm sure all of us have done it before, isn't it?
Yes.
Good. Okay, so we're going to look at this now. Can you screenshot it so that we'll be able to do it using our calculator, and then I'll definitely show you how to do it using, how to call it, using Excel, using our spreadsheet. Okay, screenshot this. So I'm going to go back to my calculator. Okay. Right, so back to our calculator. Now, we have a question like this. If a company expects to earn a compound rate of 10% on its investment, how much will it need to invest now to have the following investment? Okay, so if you expect to get 11,000 in 1 year, how much do you have to invest now, assuming your interest rate is 10%? If we expect to get 12,100 in 2 years' time, how much do you have to invest now, assuming your interest rate is 10%, and so on and so forth? That's exactly what we're going to look at. Okay? So we all agree we have to use our discounting formula, which is X is equals to V. Okay? V is the what? Feature value divided by 1 plus R raised to power N. 1 plus R raised to power N. Okay? So this is what we're coming to look at using our calculator. Okay? So the same thing. So we say 11,000 is what we expect in 1 year. Okay? 11,000 is what we expect in 1 year. So we will say 11,000. 1, 2, 3. Can you see my calculator?
Yes,
Yeah, yeah.
yes.
Okay.
Yeah.
So we say 11,000 divided by, bracket opens, okay? 1.1 for 1 year is 1.1 raised to power 1, which is the same as 1.1 divided by 1.1. So that gives us 10,000. So if we need 11,000 in 1 year's time, we have to invest 10,000 now. Okay? So I'll just do the third year because the second year is the same, so we can move fast. So let's say we want 13,310 after 3 years, okay, with an interest rate of 10%. How much should we invest now? So we say 13,310, 13,310, right? Divided by, bracket opens, 1.1 raised to power 3 for 3 years gives you 10,000. Okay, so is that clear? Can you do this on your calculator, please? Can you do this on your calculator?
Mr. Governor.
Yes. Yes.
Can you please repeat this one? Can you please repeat this one?
Yes. I'll repeat it. Don't worry. I'll repeat it. Okay. So what we are trying to do now is we are trying to discount. Okay. What do we mean by discounting? We want to make an investment. Okay. For example, we have something in our mind that in 5 years' time, I want to get, let's say, 500,000 in my account. So if you want to get 500,000 in 5 years, and the bank can give you an investment, interest rate of 10%, now you have to ask yourself, how much do you have to invest now? So in other words, there is a future value. You want to know what will be the present value of that future value. That's what we call discounting. That's exactly what we're coming to do. So put it into perspective here is, the C part says, if you need 13,310 in your account after 3 years, okay, how much do you have to invest now if the bank is going to give you an interest rate of 10% per annum? Okay, so in order to do that, you have to discount. The 13,310 will come in after 3 years. So that means this will be a value of your investment in 3 years' time. So if you want to find the value of that investment now, you have to discount it. So to discount it, you need this formula. So we say the feature value, which is 13,310, we divide that by, okay, our interest rate, sorry, our 1 plus interest rate. Our interest rate here is 10%, isn't it? 10% is 0.1. So 1 plus 0.1 is 1.1. Okay, so 1.1. Okay, but we need this in 3 years, so we need to raise it to power 3 for 3 years. Okay, so after doing that, then you have your present value as 10,000. Can you see? Is this clear? Mamat?
Yes, it's clear now, yes.
It's clear now. Excellent. Excellent. So please, everybody try to practice this in your calculator. Try to practice this in your calculator because we need this for our DCF techniques. If you know how to do this, then you can do DCF techniques easily. If you know how to do discounting, then you're fine. Okay? So this is what we're coming to do. So I hope everybody's comfortable with it. Everybody?
Yes, I think so.
We are all fine with it?
Yeah, I think people should be acquainted with this.
Huh?
I think we should be acquainted with this.
Okay, you are acquainted with it. Did you say?
Yeah, that's what I say. Because financial management and corporate finance, if you have done those two courses, you should be doing this discounting issues.
Okay. Okay, so that means you've done it before, Makam.
Yeah,
Okay.
we've done it before this.
Okay, good, good. And you are good at it, huh?
Yes.
Mm-hmm. Okay, good. Wonderful.
For
Yes,
when
I think so.
I was on a
You were on?
I was on a participation sabbatical. I missed some lectures, so I was trying to catch up.
Oh, wow. You definitely need to catch up.
Yeah.
You need to catch up.
I was on a participation break.
Oh, okay. Okay, that's all right. That's all right. Okay, so let's move, please. Let's move. Right. So you're all comfortable with discounting, just like Makam says. You've done it before in previous studies. Okay, fine, good. So we can move a bit faster. So now we know how to do our compounding. We know how to do our discounting. But discounting, as accountants, like I said, we always want to come with our own, simple formula. We know how to do discounting using a formula. But as accountants, instead of using a formula, instead of taking the feature value and dividing it by, how to call it, 1 plus the rate raised to power, n, we always take the feature value and then instead multiply by what we call a discount factor. Okay, so when you look at the formula, it's just a question of tilting the formula a bit. It gives you the same thing. So that if you calculate your discount factor, which is the same part of the formula, you just need to multiply the discount factor by your feature value to arrive at your present value. Simple. Okay. So to do that, like for example, if you have in the second one, if you have, let's say 12,100, 12,100 is the cash flow after 2 years. Okay, so 12,100. If you want to find its present value, we say 12,100 divided by 1.1 raised to power 2. Okay, when you're doing that mathematically, it is the same as 12,100. Okay, 12,100 divided by 1 multiplied by 1 over 1.1 raised to power 2. Is it not the same mathematically? if you say, let me repeat this. If you say 12,100 divided by 1.1 raised to power 2, is that not the same as 12,100 divided by 1 multiplied by 1 divided by 1.1 raised to power 2? Is it not the same? Mathematics.
Yes, it is the same. The one on top and the one of the numerator and the denominator, they will cancel out.
They will cancel each other. I like that, Umar. Thank you. That is it. The one at the bottom and the one on top will cancel each other so that you are left with 12,100 divided by 1.10 raised to power 2, we started with. Okay, so if that is the case, now the 1 divided by 1.1 divided by 1.1 raised to power 2 is simply our discount factor. Okay, let me show this on Excel so that the rest of you can understand, because it's really, really important. When I was doing this, nobody taught me how you could easily find their connection. How do you arrive at your discount factor? But I was able to do it myself until I come with a simple way of doing it. So please let me do this on Excel, and then you can understand, the way Umar understood it. So I just present my spreadsheet. Okay, so I'm going to insert a new worksheet. Don't worry, this one we're just going to project. So can you see my spreadsheet? Can you see?
Yes, we do.
Okay, so what I was saying, if you take any of them, is fine. You can take 12,100. If you want, you can take 13,310. If you want, you can take 11. If you take any of them, is fine. So what I want to show you is, if you want to do your discounting, sorry, our discounting formula is this. Okay, our discounting formula is what? V is equals to, what is V? What is V? Sorry, not V, it's X. X is equals to E, which is the feature value, divided by 1 plus R
raised to power n.
1 plus R. Yeah, you cannot see it yet because I've not entered it. 1 plus R raised to power n. Okay, this is our discounting formula, isn't it? X. What is X? X is the value now. Is what we are finding when we are discounting.
The X is the present value.
Now is equals to the feature value, which is always given to us in a discounting situation, divided by 1 plus R raised to power n. Is that not our discounting formula? Now, let's try to work this and then see how we can derive our discount factor from this. So let's use this formula to say, do the second one. The second one, we're trying to find X, and the V is given to us. What is the V?
V is the feature value.
Okay, and what is it in the second one, in the B one, where it says 12,100 after 2 years? So our V is equals to 12,100, isn't it? Are we together? Hello?
Yes.
Yeah.
Okay, so what we are saying is, if we want to find X in this situation, we are going to say 12,100 divided by, bracket open, 1 plus 0.1, okay, raised to power what? Raised to power 2, because this time around we want it for 2 years. Okay, this is what we're going to do, isn't it?
So yes, why is
yes.
Yeah.
But yeah, there's no plus. You write 0 instead of plus.
Why the zero? The zero.
0.1 is the same as 0.1.
But
There's
are
no
you
plus. Okay,
putting
sorry,
1
sorry.
point?
Okay. Okay. Sorry, I wanted to say 1 plus instead of 1 point. Okay. So that's the way it should be. So it's 1 plus 0.1 raised to power 2. Is it clear now?
Yes, it is.
Okay. Now, so what we are saying is, if we want to break this down mathematically, is this not the same as 12,100 divided by 1.1 raised to power 2, 1.1 raised to power 2, okay, 1.1 raised to power 2.
Yes, they are the same.
So what we want to say is this 12,100 divided by 1.1 raised to power 2. Is it not the same as 12,100 divided by 1, okay, multiplied by 1 divided by 1.1 raised to power 2? It's the same.
Yeah, it's the same.
It's the same. So now, this multiplication, this 12,100 divided by 1, is it not the same as 12,100? So it will give you 12,100. Multiplied by, will be multiplied by this 1 divided by 1.1 raised to power 2. This V is just to say raised to. So raised to power 2, this is what we are, this is what we call a discount factor. Okay, so this is what we call our discount factor. So we find our discount factor and then multiply the feature value with that to give us our present value. Okay, so this is the way we get our discount factor. So instead of using this formula, we just find our discount factor and then multiply by. So this formula, you have seen it. It is the same as taking the number and multiply by the discount factor. Is that clear now?
Yes.
Okay, excellent. So after putting that into consideration, let's look at the 4.2.1 quickly so that we can go and do our NPV analysis quickly. Okay, so the 4.2.1, so the first part of it, I'll just do it on here. So after 1 year, after 1 year, then after 2 years, and after 3 years. So after 2 years, then after 3 years. So after 1 year, what is our V? Our feature value after 1 year is how much?
11.
11,000. Good. Okay, so let me format this to 3DP, sorry, to 1,000 separator and 0 DP. So 11,000 after 2 years is
12,100.
12,100. After 3 years is what?
13,310.
13,310. Right. So these are what we call our feature values, or V. So just put that here. Feature values in brackets V. Okay? So these are feature values. Now, we are not going to use our formula, just like we've done here, but instead we are going to calculate a discount factor. and our discount factor for the 10% for 1 year, for 2 years, and for 3 years is what we're coming to do here. And then we'll have our PV, our present value. Okay. So now, how do we calculate our discount factor here? Can someone help me? Malcolm, you've done this before. So can you tell us how we calculate our discount factor? Malcolm? Yes, tell us how we calculate our discount factor, please.
A discount factor
yes.
of 10%.
Yes.
Just 1 over 1 divided by.
What divided by?
1 divided by.
So give me the
1.1
formula.
for the power 1 for the in the first year.
Okay, you say equals?
Type 1. Yeah, equals 1. Yes, equals 1. Divided by.
Divided by?
1. Yes, 1.1.
1.1
to the power 1.
How do you put to the power 1?
Yeah, that reverse, I would call it reverse V, whatever.
Okay, reverse V.
Then 1.
Okay.
Yes, I'm seeing it. It's working. Yeah.
Okay, it's working. Fine. Good.
Then your decimals, you can put them to whatever you want.
We can put them whatever we want.
Yeah, maybe 4.
No, we always take them to 3 decimal places.
3, okay.
So if you have not been told in exams, you always take them to 3 decimal places.
Okay.
Okay, 3 decimal places. So right, okay, that was a good attempt, but in order for us to take it to 3 decimal places, we need to round it up. Okay, so follow this. How do we round it when we are calculating? Of course, when you are using your calculator, you're going to say 11,000. You're going to type 11,000 multiplied by 1.1. Okay, either the reverse V. You can use either the reverse V or the y to the power x key, or the key that says x to the power y. Okay, so either of any of those 3 can be able to do it. Okay, and after pressing that key, then the number of years will come. If it is 1 year, you press 1. If it is 2 years, you press 2, and so on and so forth. Okay, but in Excel, if we are calculating and we want to round it up to 3 decimal places, we always start with a round function. So you say equals round. This round function will round it up to the number of how to call it, places you want it to round it up. So we say equals round, bracket opens. Okay, so what do you want to round? You want to round a formula which is 1 divided by 1.1. Okay, so you put that in brackets. It's safer to put it in bracket so that you don't make mistake. 1 divided by 1.1 in brackets raised to power 1 in our situation here. Okay, raised to power 1. Then you have comma. You want to round it to 3 decimal places. Okay, you want to round it to 3 decimal places. You enter. So that will give you nicely rounded to 3 decimal places. And then you copy. Once you copy, you need to change the second one. Instead of raised to power 1, you're going to say raised to power 2. You enter. Then that will give you 0.826. The third one, since it's 3 years, instead of raised to power 1, because we've copied the formula, so you change the 1 to 3 years, so you have 0.751. Is this clear?
Yes.
Okay.
Yeah.
So now, if we want to find the present value, it's going to be this multiplied by that. We enter. We replicate. Yes. Hello, someone wants to say something? Hello?
Yeah, sorry, Mr. Favana.
Yes.
Yeah, I'm really having really big problem about network. I just get in now. So, yeah, a discounting formula with question on that, please.
Sorry?
Is it discounting on a discounting, right?
Yes, we are discounting, yes.
The question is trying to solve. This which
Question
question
we're
is
trying to
that?
solve, the question we're trying to solve is on page 8,
Oh, okay,
4.2.1.
okay, all right, okay, thank you.
Is that clear?
Yeah, thank you, sir, thank you.
Okay, Mr. Fofana.
Yes, sir.
Yes, I'm using Excel here, so I'm trying to do the discounting factor for the first year.
Yes.
But it seems it's not working because
It's not working?
okay, let me check this one because I close the bracket, then I raise to power 1 for the first year. So I don't know whether that one is not working. I don't know. Okay.
Not working?
Yeah, it's not working.
Okay. Did you use this formula? Can you see the formula?
Yes, so open it and so that I can see.
Okay, 1 second. Okay, that's the formula equals.
Okay.
Round.
Round, yes.
Okay, 1 divided by.
Can I open bracket?
Yes, you have to open brackets.
Bracket open, then 1 divided by.
1.1.
1.1.
Raised to power. Raised to power, you use the key on top of 6.
Yes.
Okay?
Yeah.
Okay, raised to power 1. You close the bracket, comma.
Comma.
Okay, and then you round up to 3. So you do 3, you type 3 and then close the bracket. You enter.
Mr. Bawan,
Yes.
what about this when you are putting this round in the formula? Or you can also do it. You can just put the formula there, then after you go to format, then reduce the round it up there. So
yes.
It can be possible there also.
You can, for example, you can put the formula there.
Yes, then after you enter, then you can go to formatting, then round it up there.
Okay, for me, I need to open bracket twice. So that one, has worked.
It has worked. Good. Okay, fine.
Yeah. Open bracket twice.
Good. You
And
open
close
bracket twice. Okay, good. Okay, so what you are saying, let me just get that. So what you are saying is we say equals 1 divided by bracket opens 1.1 raised to power 1, for example, close the bracket, we enter. Okay, so we have this. Okay, and then you can come here and then round it up to 3dp. Yes.
Yes. That's
That
what I
is
mean.
correct also.
Yes, that's what I mean. Yes.
Yes, that is correct also. Raised to power 2 and then raised to power 3. So that's correct also. So you can even do without the rounding as well. Okay? Okay, so that is also correct. Can you see? Okay, so I think that has nicely taken us to our main topic, which is the net present value method. So it's once you know how to do your discounting, the rest becomes very, very easy for you. Okay, so we're going to go to our NPV method now. Any questions on discounting and